Hello, how are you? I want to continue talking about pointers, and in this case, I'm going to use another term. I'm going to call what we were looking at last time a linked list. This is the structure that I used to implement the waiting line as a queue. It could be used to implement many different things, but I did it as a queue because I thought that was a more obvious way you might see something. Now in the video, I represented the queue as the front here and the rear here, and each person in line knowing who is behind them. The way I will show that pictorially is this. Each box represents a node or a person, except for the front and rear, and they represent pointers to, in this case, persons. The pointer points to the entire person. It doesn't point to one half of it or one part of it. It points to the whole item. Now, I draw it this way, and it represents a node. We call that person in the waiting line, and that's the name I'll use later in this. So these two statements here do the following. Pardon me, I have to move a few things down. It creates the node, and it creates a pointer, and puts the address of this node into the pointer. Now I call the pointer temp. Doesn't have to be called temp. It could have been called anything. There are two ways to get at this node. We do not have a name for it. It's anonymous. We have a pointer to get to it. So we can write temp point to. That's the variable that temp points to. Then another way of writing it is asterisk temp. What this is the address of temp, or where temp points to. The asterisk approach is called deaccessing the pointer. In much of this material we're going to be doing, the asterisk basically means address where something is pointing, or it gets us to something. So you'll notice here, temp star is a node. So node asterisk temp is a node. So asterisk temp is a node. Now the slight incongruity is the two way things are done a little differently. If I want to print out the name that is in temp, and I use the temp point to, I put the name of the field here. The part of it, that's called the field. If I'm using asterisk temp, then I have to view it as a struct, and I have to use the dot notation to get the piece of it. These two did exactly the same thing. They printed out Mary. Now I'm going to switch to talking about the waiting line now. And this was in the last one. We had the struct person, and I had the class waiting line. And there's a lot of things in here. In fact, I think I've added a couple since we talked about it last time. And what I'm going to do is write a very simple main line. And the main line, it looks like I lost part of what I wanted to put in that main line. Let me see. Oh, pardon me, let's do this. What I want to do is I want to add one person. Let's see. Well, this part was just to produce the node. When I had the code up above, if you remember, and I had the temp, it was this code right here. Person, star temp equals new person, put Mary in, put now in. What that created after the code above the struct class, we have a node, and temp is pointing to it. I don't know what happened to my temp pointer. I had one. There it is. This is supposed to move down. So let me see if I can read this. Yeah, move this up. I think I can move it up. Yes. And one more. These things get difficult after a while. You have to sort of figure out just how you're going to do them. I want to get the read up here. And I want to get the next name and whatever down further. I think I better stop. All right, here's the way I'm going to do it. Pardon me. I'm going to take there. This item here is what we get after we do that. And we have that. Now I can erase this here. So we got a little item here. I didn't get all of it. I forgot this portion. Let me just put it down here. I think I want it right there. Yeah, that'll work. Get rid of this line. And rid of this. And this. And move this up a line. And that's what I want. So that's what we got. Now what I want to do is do the same thing. If you look at the add function, the add method, you'll see that the first lines of the add method are the same. Temp equals new person. Temp name equals the name. The difference is I don't set up the pointer. And I don't have to, because the pointer is initialized in the definition of struct. So every time I create a person, the pointer is set to null automatically. Now, this part here is necessary to create the waiting line. So let's see what happens when we run this. We have now Mary, and we added rear and front to point to it. Temp is gone. Now let's add a new person, Veronica. So the first three lines of code of add create Veronica. Just as we created Mary above, they create a node with Veronica in it here. Now, we still have the waiting line that we had before. Since our len is not 0, we go to the portion of the else of the code. The first clause in it says, rear point next should equal temp. Now, rear is here. Its old pointer, which was in dotted lines here, was pointing to this node. I wipe out the null and copy the pointer temp into here. Mary now points to temp. So Mary points to Veronica. But that's not enough. Now we have to fix rear. Because rear is pointing to Mary, it has to point to Veronica. So we say rear equals what temp was. And when we finish, we have these new arrows, the green and the red, and the null and this dotted arrow are gone. And that's how we hook it in. Now, that's the first step of trying to go through this in detail. You're going to have to draw these and look at them. It takes a while to think it out. When I wrote my program that I'm going to show you, I think maybe in this video, if not in the next one, it's going to show that it takes a lot of work. I had to sit and look at some things to make sure they fit. So let me show you the next part of this video. If I can bring it up. Yes, the shallow copy and the proof that shallow copy fails. You'll be able to see this better when I send it to you. But right now I can make it a little bigger by cropping it and showing you what I have here. I think that will work, and this will work. What I have is I have the code and I have the output from the code on the same screen, and only the part that I cared about. Now I created 2 waiting lines, 1 and 2. And the first thing I did was add some things to 1, A, B, C, and D. So you can see I added the 3 items. And then I said 2 equals 1. Well, as expected, you would hope that would copy it. It does. 2 is now A, B, C, and D. Then I added E to 1, and I added F to 2, and I removed the 2 items at the top of 1. So let's see if that worked. 1, I removed the A and the B, and I added E. Where is E? And 2, I added F. Why is F hiding here in this, where E should be? The problem is that the equal sign is what is called a shallow copy. What that means is that it does not really copy everything in the waiting line. The copy works as long as there are no linked lists, no pointers in what is being copied. The minute there are pointers, everything goes wrong. Because what happens is the equal sign copies the front and the rear, but it just doesn't change what they point to. So the same places exist in both of the cues. They're the same places in memory. We had to make a new copy of them if we're going to have what's called a deep copy. The shallow copy is a horrible thing. I wish they had taken it. I don't know why they didn't write it better, but they sure did. Now, I think this is the one. Let me check. I think this is the one where I wrote it. That's the shallow copy. I'm not sure that's where I wrote it. I have the program, which I can show you in a minute. See if I wrote, if it's here, or if I have to get it. I have to get it from here. So hold on a second. I'll save this. Save. And now I have to bring up this one. And I'm going to show you the new copy I wrote. It's right here. My copy. And my copy is written as a method in the class. I attach my copy to what I want to be the copy. The old thing I'm copying is the parameter I pass. Now, what that means is that when I use front or rear, I'm referring to one. I am creating a new item. I'm referring to the new item, the copy. If I want the pieces of one, I have to put one in front of it. I repeat, there are two waiting lines here. You see one of them right there, one. But it is not what this method is attached to. This method is attached to another item. In fact, if you see it when I use it, you'll see that 2 is the new waiting line. So 2.myCopy1 says copy 1 into 2. That's what it's about. Copy 1 into 2. Since 2 is what I'm working with, let's see where I put it, up here, then whenever I say len, that refers to the new one. Whenever I say front, it refers to the new one. Now this is a rather complicated little problem here. First of all, I find out how much I have to copy. So now I say, I'm going to need 3 temp variables that are persons. 2 of them are going to be for the new list, and 1's going to be for the old list. The first thing I do is create a new person. That's going to be the first person in my new list. So front equals temp new 1. Front is now pointing to what I want to be the copy of the first person in 1. So temp new 1 name is whatever front is pointing to's name. So I take the first person in front points to the first person in 1, and I take that name and copy it into the name of my first person in my new line. Then I say, all right, temp old is going to be 1 front. So it's pointing to the first person. Temp new 2, I start off as null. I'm going to have 2 pointers walking down the new one instead of 1. Now, I look. Is there anything more to copy? Well, I look at temp old. That's front, remember? The first time. I look at its next. what it's pointing to, and I see if there's anything it points to. That would mean there's another one that I haven't copied yet. So I create a new person in temp2, temp new 2. I make temp new 2 the name, and this is double in direction. Take tempo, point to next. That's the person I haven't copied yet, and take their name and put that into the new person's name. Take temp new 1, which was the last one I copied, and have it point to the new one. That's why I needed 2 temps. I needed to have both of them together. I probably could get around it, but I found this worked better for me. Then, as I often do, I move things down. Temp new 1 is now pointing past where it used to point, to the last thing I put in. Temp new 1 always points to the last item I copied. I have to change tempo because I have to keep moving down the old list, so it's just tempo next. Now I keep doing that till I get a null. When I get the null, I'm at the end. The last item I added was temp new 2, so I have here point to temp new 2. And I've set it up. It's a new list using new places, and it did work. I have it right here. This was the second one. Again, let me make it bigger. And go up here. All of a sudden, nothing will move. That's par for the course, I'm sorry to say. All right, maybe. This is frustrating. I don't know why this is happening. All right, I think I did it there. So, let me pull this over now. This time, if you look, when I added the E, it went into the first item. And when I added the F, it went into the second Q. So I think it worked. I hope it worked. It seems to work. But this problem was sort of a tour de force, to be honest with you. It is not easy. You have to really work it out with the diagrams. I have here a card sitting next to my computer where I actually wrote out the things as I did it so that I could keep track of what was what. Without it, I would not have been able to do it. So the point of all this is that, unfortunately, the equal sign, when we use it to copy a structure, or a class, does not work if there are any pointers in the class. It just doesn't work. The reason it doesn't is technical. It's actually not the pointers. It's where the computer gets the memory for the pointers. It gets the memory to create these new items it's creating from a portion of the user's memory called the heap, H-E-A-P. And this is a dynamic allocation. That is, it's done after we stop running the program. And the shallow copy refuses to copy anything that's in the heap. It just won't do it. So we have to do it if we want to have a real copy. There's no other way around it. So that's it for now. Don't get too discouraged. Pointers are not easy. They take a lot of thinking and a lot of working, especially when you don't draw a diagram to look at it. I would suggest that when you're playing with these, you try to draw diagrams like the one I had here. You see how I knew what was happening. I put the original down, and then I showed what changes were made at each step. It's easy to do if you're not drawing in Word, because you can just erase things or cross them out. The closest I could come to crossing out was Xing out these, and here the best I could do was use a dotted line. In PowerPoint I could have done it, but I didn't feel like doing PowerPoint. So that's what we have. I'm probably going to give you another example soon, and I think my next video will be on the wonderful world of recursion, one of the most interesting ways of programming I've ever seen. It's fun and can get you into every kind of trouble you could possibly get into. So we'll play around with that in the next video. See you later now.